Hi, this is Josh Carlisle. Thanks for joining me on one of the final Azure Advent Calendar topics of 2019. I wanted to make a big shout out to Gregor Suddy and Richard Hooper for all the hard work they did putting this together. And of course, all the rest of the community have put together a lot of awesome content. In this talk, we're going to learn how we can achieve event-driven serverless containers in Kubernetes with Azure Functions and KEDA. Just a quick little bit about myself. I'm out of Raleigh, North Carolina, on the east coast of the United States. I've been a developer, consultant, and trusted advisor for over 20 years. From a developer and architect to a development team lead and manager, if there's a developer hat, I've likely worn it at some point in time in my career. I've been contributing to the community for over 15 years, and I'm also a Microsoft MVP with Azure. My day job is with AppDynamics, which is part of Cisco, where we make an awesome APM product, and I help our partners and customers work with it on Azure. So before getting started, it's useful to level set a bit on the definition of serverless, especially since Kubernetes and serverless have historically been considered on fairly opposite ends of the spectrum. In fact, until recently, it's been seen as an either-or type decision between Kubernetes and serverless platforms, such as Azure Functions. One of my favorite definitions is actually provided by Ben Kehoe, who is pretty prominent in the serverless community. First off, serverless is serverful with ephemeral compute. So serverful essentially means it relies on external services and building blocks. And of course, ephemeral compute means that the computing infrastructure should not have to be continually running on the platform. The ephemeral compute also implies that scaling needs are greatly simplified and are largely transparent. Secondly, is how you are billed is a key consideration, and you should only be billed for resources that you're actually used. Most folks are familiar with the pay-per-execution model in serverless today. And lastly, it should have a smaller and abstracted control plane, meaning you have fewer dials and knobs you're responsible for keeping an eye on, but at the same time you have no maintenance or management responsibilities that really distract you from what is intended to providing the core business value for your application. So this takes us back to Kubernetes and where it falls on the spectrum of serverless that will lead us directly to the focus of this talk. Now, most folks understand and appreciate that the concepts like virtual machines and cloud-native serverless platforms like Azure Functions currently sit at either end of the serverless spectrum. Now, in general, native Kubernetes aligns pretty closely with traditional compute when it comes to the serverless spectrum. Traditional virtual machines still drive the underlying infrastructure of Kubernetes, from the platform itself to the containers you host, which you're required to maintain yourself. Scaling that platform requires additional resources that also have to be allocated. So in general, we're talking persistent compute and the costs associated with it alongside a fairly complex control plane. Then comes along managed Kubernetes service, such as Azure Kubernetes Service, also known as AKS, that greatly simplified the control plane creation and the management by offloading all of that to Azure and making elements of it free. And it has certainly simplified adding additional compute resources, so it's a great story about reducing the complexity and some of the costs associated with it, but still pretty far from serverless. Then we go and add the virtual kubelet for AKS, where we now start to really blur the lines between Kubernetes and serverless, especially when combined with services such as Azure Container Instances, a serverless container hosting platform on Azure. Now, ACI is not a container orchestrator, but it is a container hosting platform where you only pay for what you use. So now, instead of being limited to resources you have directly provisioned on your Kubernetes cluster, you have virtually endless supply of resources immediately available to you that you only pay for what you use. Now that sounds like we're almost there on the edge of the serverless platform, but that's where today's story picks up. We still have the challenges in how we scale and the way in which we scale our resources, and that's where KEDA comes into the picture. So KEDA is Kubernetes Event-Driven Autoscaling. It's intended for event-based architectures that are very common in today's microservice architecture. A very common example is asynchronous patterns built around modern messaging platforms like Azure Service Bus or Kafka. Now, KEDA provides additional features to Kubernetes to scale your Kubernetes cluster to meet your needs based on the number of events coming in. This allows you to be much more proactive when it comes to handling your workload. Now, KEDA is also cloud agnostic and open source. KEDA was actually developed in an effort by Microsoft and Red Hat and the Kubernetes community. It can run on Kubernetes anywhere, whether that be in Azure, AWS, Google, or even on-prem. Although discussed here in the context of serverless, it does not have to actually make use of features like virtual kubelets, although there is, of course, a lot of advantage to do so. Now, KEDA is native to Kubernetes and is deployed as a custom resource on your Kubernetes cluster. You may also be wondering why Azure Functions is on the KEDA slide. Well, it turns out that Azure Functions has first-class support for KEDA as well. We'll talk a little bit more about that later. So KEDA is intended to fill a very specific role of providing event-based scaling to Kubernetes. It's not a turnkey serverless solution for Kubernetes like Knative, but instead it's an important element of bringing some more of the benefits of serverless to Kubernetes. So let's take a quick closer look at what traditional scaling looks like on Kubernetes. In this case, we have a messaging platform that our application is listening to for new messages on. We have a subset of containers running in pods deployed to a node in our Kubernetes cluster. Now remember, at the end of the day, this node is a VM that you're paying for. Now, as more requests start to come in, we'll get more containers deployed based on some of our horizontal scaling rules. But at a certain point, however, we reach capacity on our node and we have to make some decisions on how we want to scale. This typically means adding additional nodes for capacity. Just as important, we also have to keep an eye out when we need to remove resources that are no longer needed. Now lastly, remember that Kubernetes doesn't have any visibility into how many messages are in our queue, just how hard our current resources are working, and making some assessments on potential need for new resources based on that. Now in this case, when using virtual nodes, things start to look a little different. As load increases, we are still scaling based on traditional hardware rules, but instead of worrying about having enough nodes, we have a virtual node that we can scale into with the added benefit of we only paying for what we use. So now we have KEDA in the picture. We're still running our containers in the virtual nodes. They are running in Azure container instances. However, instead of scaling rules being driven by hardware, we have instead configured KEDA to look at our Azure storage queue to understand how many messages we have and scale our cluster appropriately. Now, just as important to understand is when we need to reduce our cluster size, potentially scaling down to 0. So why are we combining this with Azure Functions? Well, we certainly don't need to. There's no dependency to do so, but there are sure some advantages to it. Well, we already know that Azure Functions is a fantastic event-driven framework, so at its core it aligns very well with KEDA. With its support for bindings and some super powerful features like durable functions, we are really attracted to the productivity that we can get out of the platform. And Azure Function, of course, also supports container deployment and has baked-in support in its tooling for not only containers, but Kubernetes and KEDA as well. And lastly, we have the flexibility to run Azure Functions anywhere. So we have the flexibility developed natively for Azure Functions running on Azure, but also if we have some unique requirements, we can also take advantage of running Azure Functions on container platforms such as Kubernetes. So enough with the slides. Let's go ahead and see some of this in action. It's also worth mentioning to give you some context. If you haven't used Kubernetes before, don't be intimidated. I'm coming from a serverless first perspective and background, and I historically have only kicked the tires a bit on Kubernetes, and I found the process for getting started pretty straightforward. Of course, your mileage may vary, and I'll give you some resources at the end of this talk on where you can go to get some additional help. So first off, we have a couple dependencies that we want to talk about before we get started. I've chosen to use Visual Studio Code as it's a fantastic platform and has some great plugins for Azure and Azure Functions, but you can of course use your editor of choice. I'll try to stick to using the command line as much as I can to keep the experience consistent as possible, regardless of your editor though. Now don't worry if you're not a dev, we won't be spending a lot of time in code. You will, however, need to install the Azure Functions core tools, and I highly suggest also installing the Azure CLI, although you can also follow along in the Cloud Shell in the Azure portal if you'd like. Now it goes without saying that you'll need an Azure subscription to follow along entirely, but if you only have a local Kubernetes development cluster, you could likely also use that as well. But once again, I'll provide some useful links at the end of this talk to help you get started with KEDA in general. So first off, let's take care of our application needs quickly. For the purpose of the demo, we're going to go ahead and create an Azure function locally, create a new storage account queue that the function will process, and finally we're going to package it up and deploy it as an image to Docker Hub. Now to make this all easier, I'll be copying and pasting some of the existing commands in the terminal. As for the more folks I believe are watching, the worse my typing usually gets. So first off, we're going to go ahead and create an Azure resource group. Now this will be used by both our queue and our eventual AKS resources that we'll be deploying. In this particular case, we're going to create an Azure resource group in East US, and we're calling it Azure Advent KEDA. Now, creation of that is pretty quick, so we'll go ahead and move on to creating our storage account for our queue. So this will create a new storage account in the East US once again in our resource group that we just created. And this storage account will have a name of Advent KEDA STG. So now that we have our storage account created, we're going to go ahead and grab our connection string because we're going to be using that in the next couple commands that we need to run. So this is going to load up the connection string for that storage account into a variable there. And then we're going to go ahead and create our new queue. This queue is going to be called the KEDA queue, and it's going to be created in our storage account with the connection string that we just set. Now that we've created the queue, I actually want to grab and view the actual connection string. We're going to use that later when we actually create the Azure function. Now it's worth mentioning for any of you who are interested in copying that actual connection string that is valid, this is actually going to be deleted after the demo, so you won't have any luck having any fun there. But now that we have that connection string, the last thing we want to do is we're actually going to add a message to the queue. That queue message is going to be there so that we can test in a little bit once we have created our Azure function. And with some luck here, we now have a message waiting in the queue with some content of hello Azure Advent Calendar fans. So now that we have our resource group created, we have created our storage account and our queue with a message waiting, let's go ahead and move on and create our Azure function. So we're now going to use the Azure Functions CLI to initiate a new function. Now keep in mind, we aren't going to actually be deploying this function in Azure. To Azure Functions. I know it's kind of confusing. Azure Functions is both a service on Azure and a framework and runtime, but we're just going to be doing this locally and packaging it into an image and deploying that image to Docker Hub. So we start that process by using the func command, init, and we're just going to initialize it in the current directory. And in this particular case, we're going to use the Docker switch. So we want to actually choose the .NET runtime. You could choose, obviously, the runtime of choice that you would like. I'm a .NET developer, so I'd like to use a .NET runtime. Great, and we've already gone ahead and created that. Now, at this point in time, we actually need a function as well. Right now, we just have essentially an empty project. And a Docker file, which we'll be looking at momentarily. But we actually want to create a new function. In this case, we want a function that listens to a queue. So we can go ahead and say func new. And it's going to give us some options. We're going to choose a queue trigger. And we're going to call this the KEDA queue trigger. So we've gone ahead and successfully created our trigger. Now at this point in time, I'm going to go ahead and leave the command line. I want to get a little bit of the developer experience, so we're going to go ahead and open up this project in code. So now that we're in Visual Studio Code, we're getting some warnings that we created the project outside of code. So we're going to go ahead and let it initialize our project. We may get a couple of these prompts along the way from both Visual Studio Code and Azure Functions extensions, wanting to make some project updates. We'll let them whenever we get prompted. They're going to help us do things like adding debugging support. But now we have a few things that we want to quickly update within the project before we can get it packaged up. Go ahead and finish initializing with code. And we're going to make this just a little bit bigger so we can work with this a bit. And we're going to make our font just a bit bigger so you can see a little bit. There we go. So I want to call out, as you can see here, it has created a Docker file for us. So we have everything we need to do to get a image created for us. But a couple of the areas that we want to update. The first thing we want to take a look at is the local settings. So you can see here we have our Azure Web Job storage, and it's currently empty. We want to go ahead and go back and take that connection string that we had before and copy it in there. Okay, so now that we have that in place, we're going to go ahead and copy this property value name here, and we're going to go into our actual trigger, and we want to go ahead and update our connection. So it's going to use the Azure Web Job Storage connection string for that. And if we go back, we can see that our queue was named KEDA queue. So we want to make sure that the queue it's being triggered off of is also the KEDA queue. Now, one of the things that we're going to do a little bit here, and this is largely inconsequential, but does simulate some artificial processing, load processing. I'm going to copy a few code snippets over into our project. And we're going to make sure that we call that snippet whenever the function is triggered. And once again, this is just creating some artificial load for us. That'll help us see some activity once we go and run it and load this once we deploy to Kubernetes. The other thing that we want to go ahead and update is the host file. Now, this host file is not something that you would normally do in production. This is, once again, this is going to help us facilitate a little bit of seeing the activity that we want to see when we want run this under load. And what this is telling us is that this is giving directions to the Azure Functions runtime to only process one of these batches at a time. Obviously, we would not want to use this in production. It's going to reduce our ability to make use of these instances to process multiple requests at the same time. But this will trigger some increased scaling so we can see KEDA in action. Now, before we go ahead and package this up, we should test this locally real quick to ensure it's working and that it will work once we deploy it to Kubernetes. Now, if you recall, we already have a message waiting in the queue, so this should trigger relatively quickly. So we'll go ahead and set a breakpoint to ensure everything is working as expected. And then through the debugger, we'll go ahead and run this. And it should go through all the .NET Restore and the .NET Compile. And then the Azure Functions runtime is going to go ahead and launch. And our message has been triggered. And if we look at the details here, we can see hello Azure Advent Calendar fans. So at this point in time, we know that our function is running, and it's running appropriately, and it's working with our queue. So the next step is to go ahead and create a new Kubernetes cluster in Azure. This time we will change it up a bit and go into the Azure portal to create our cluster. We are currently in the Azure Advent KEDA resource group. You can see our existing storage account that we created earlier. We're going to go ahead and add a new resource. Now we're going to call this Azure KEDA. Actually, we'll keep with the theme here. We'll call this Azure Advent KEDA. And I created the original in East US, so we're going to go ahead and put it in the same region. And here we'll just go ahead and stick with all the regular defaults, and we'll move on to scale. Now we want to make sure that virtual nodes are actually enabled, because we're going to be using those. And just for our purposes here, we're pretty much going to stick with a lot of the defaults just to kind of facilitate getting this created. And now that's been validated, we'll go ahead and create this. Now we'll go ahead and pause for a moment and wait for this to complete. So through the magic of video, we are all done with our AKS deployment. We can go ahead and jump into our resource group. And we now see that we have a couple new resources here. We have a virtual network that AKS uses and our AKS cluster. Now let's go ahead and switch gears and head back to here. And let's go ahead and we're going to set up our cluster to use KEDA. So I'm going to open up a new terminal here. So the first thing we want to do is we actually wanted to tie in kubectl to our new AKS cluster. So we can do this through the Azure CLI. I have a command already handy for it. So this will make sure that when we actually execute kubectl commands, that they will be executed against our new AKS cluster. So let's go ahead and run a command to test this. And perfect. We really don't have anything going on. This is what I expected to see. So the next thing we want to do is we actually want to install KEDA on our cluster. And we can do that through the Azure Functions CLI. But before we do that, we're going to go ahead and create a quick new namespace as well. We're going to call this Azure Advent. Okay, oops, let's go ahead and close that by accident. So as you can see now, we've installed KEDA, and it's installed all the dependencies that are required for KEDA onto our cluster. The next thing we want to do is actually build a deploy for this. Now there's a couple different ways we can build a deploy, and it's different depending on whether we're using virtual nodes. In this case, we are. So we're going to go ahead and run another func command, and just as a reminder, those func commands are part of the Azure Functions CLI. Okay, and this is going to go ahead and create a deploy YAML file for us that we're going to need to update. And it's giving a little bit of extra information, like the registry that we're going to be using. In my case, it's my Docker Hub registry. And we're deploying it to Azure Advent. So we're going to go ahead and create this. And we can see here that it has created a deploy.yaml file within our project. Now the only subtle difference that we need to add to this, we need to open up a deploy.yaml, and we're going to see that we have a tolerations and operator that we need to add. Now if you're looking at the official KEDA documentation, be careful when you're copying and pasting in here. One of the first issues that I had with this was that I was getting YAML file errors, and with YAML files, spacing is everything. So we want to make sure that we have this in the right place. So in this particular case, we're going to go ahead and add it here. And obviously spacing is important. So we're going to go ahead and add this back to this level. And this is where the original issue that I had was caused from. There we go. Okay, so that is the only change that we have to make to be able to support those virtual nodes, the virtual kubelets from Azure. So let's go ahead and save this file. And the next thing to do is we're going to go ahead and go build our Dockerfile images. Okay, oops, and before we build the Dockerfile images, I just noticed, look, it's going to come back and bite me here. Spacing is everything. There we go. Let's go ahead and fix that. The tolerations should be at the same level as containers. So I've gone ahead and spun up a new terminal, and we're going to go ahead and build our Docker file. Great. And then we're going to go ahead and push that new file out to my repo. Awesome. Okay, and then lastly, we're going to go ahead and deploy this to our Kubernetes cluster. Perfect. So now it's out there. We'll go ahead and run a quick kubectl get deploy. Okay, we should see it's what I expected. We do not have any pods because we do not have any activity. So let's go ahead and create a new message and see if all of our plumbing and our application is running as expected. Great, so switching back to our Azure portal here. We're going to go ahead and open up our storage and go right to our queue. So we should be able to see our KEDA queue. Perfect. Let's go ahead and add a new message in here. We'll say, hello Azure Advent Calendar fans. We'll change it a little bit to KEDA fans. Okay. So at this point in time, we should be able to go back to our cluster, and we should be able to see at this point in time, what I'm hoping to see is that we have a pod spun up, which we do. So this can take upwards of 30 seconds or so. Got a little bit lucky here. So our pod is now spun up, and let's actually see if we can see what's going on in our pod here in a second here. We'll go ahead and pull some of the logs off our pod, see if we can see some of our output from our functions here. Perfect. So we can see here that our Azure function was triggered, and we can see that the content was there. It was hello Azure Advent Calendar KEDA fans. So we know our plumbing is working. We've successfully deployed. So let's see what this looks like under a little bit of load now. So before we go ahead and generate load, we're going to go ahead and jump over to the portal. And instead of viewing the status of our nodes and containers through kubectl, we're going to instead look at the Azure portal. If we go over here, we're in our Azure Advent KEDA AKS cluster. If we go ahead and view insights and go to nodes, we should see here's our virtual node, our ACI virtual node. And as I would expect, we have a single pod with a single container in it, since we just recently dropped a message in there for processing. So let's go ahead and generate some load and see what that looks like here once we've dropped a lot of messages into the queue. We're going to generate about 10,000 messages here. So let's go over to our queue real quick, and let's see what's showing up in there. Yep, okay, great. We have lots and lots of messages popping on there. And if we go back to our stats here, and we hit refresh, momentarily we should start seeing a lot of pods being created. Sometimes it can take a moment to refresh. Here we go. We're starting to see some activity. And while it's doing that, we'll switch gears here and come back here. And let's run our last command again. Okay, we can start to see 3 out of 16 already. Sometimes those Azure metrics lag behind a little bit. We'll switch gears and go back there in a second. But we can see 3 out of 16, so we can see we're quickly spinning up pods because KEDA has recognized that we have a lot of messages in the queue to process. So it is responding to those messages in the queue by creating more instances for us. So let's go back here and see what this looks like now. We're still lagging behind a little bit there. I think this is more of a measure of, there we go. Okay, now we're starting to see some things. So we can see some things warming up, and we can see some pods that are already ready. And this trend will continue. We can see here that we've very, very quickly spun up lots and lots of pods because, of course, I just dropped 10,000 messages into our queue to be processed. So as you can see, in about 15 minutes, we created an Azure function, deployed and configured a new Kubernetes cluster on Azure. We deployed and configured KEDA to that cluster, and we were able to see KEDA in action, quickly scaling to meet the needs of a massive amount of messages. So in this particular case, we saw Azure storage queues being used, but KEDA supports many other types of event types, and this list is continually growing. Here are some of the resources you might find helpful if you're interested in learning more about KEDA. I hope everyone has a fantastic holiday season. Feel free to connect with me over on Twitter or LinkedIn for more conversations.